Students, this is the continuation of previous stereochemistry classes. I, Dr. Srirupa Banerjee, Department of Chemistry, Bethune College, will teach you about the conformation of various substituted alkanes. All you know about ethane, the structure of ethane, and if we draw the if we draw the energy profile diagram of ethane starting from this eclipsed conformation, purposefully I am giving this two hydrogen red in color, and rotate this one at 60 degree, we will get the staggered ethane. Again 60 degree, we will get eclipsed ethane, then 60 degree staggered, eclipsed, staggered, eclipsed, and this is nothing but this one, that is previous molecule. And this is the energy profile diagram against a potential energy and dihedral angle. All three conformers, that is three staggered conformations, or since these are the energy minima position, say they are conformers. These three conformers are of same energy, and again these three eclipsed conformation are also of same energy, because these two hydrogen, these two hydrogen, these two hydrogen in all cases, and this is nothing but this. So all the eclipsed conformation have the same energy and higher energy than the staggered one, and staggered conformations or three conformers are of same energy, and the energy difference between this staggered and eclipsed conformation is 3.0 kilocalorie per mole. This is our conformational analysis of ethane. Now the conformational analysis of propane. Propane means CH3, CH2, CH3, and this if we draw a bond, this means a methyl. If we draw nothing here, it means here is two hydrogen. So this is our convention. This is propane molecule, and if I start the conformational analysis of propane from staggered one, then these two is in eclipsed condition, that is methyl and hydrogen, and in other two groups are in both cases hydrogen. Now I am rotating this methyl clockwise 60 degree, then 120 degree, previous like previous molecule, 180 degree, 240 degree, 300 degree, and then 360 degree, which means the similar conformation. Now in all staggered cases, these are of same energy, because there is only one methyl group over here. 5 hydrogen, 1 methyl, 5 hydrogen, 1 methyl, 5 hydrogen, 1 methyl. So these are of same energy, and this eclipsed conformation again of same energy, because these two only one methyl hydrogen interaction and two hydrogen hydrogen interactions. One methyl hydrogen, two hydrogen hydrogen, one methyl hydrogen, two hydrogen hydrogen, and this is the identical one. So they possess also same energy, but eclipsed conformation has higher energy. We know about that, since hydrogen and methyl are eclipsing condition, and staggered one are of different energy, since they are in the relation of 60 degree dihedral angle. Now if we draw the energy profile diagram of propane, then we also see that these are the type of the energy profile diagram is exactly same with that of ethane. That is all staggered with same energy content, all eclipsed with same energy content. Now what is the difference between these two graphs? If we saw carefully, we will see that the two energy difference between two conformation staggered and eclipsed is 3.0 kilocalorie per mole for ethane, whereas for propane this is 3.4 kilocalorie per mole, and this is because of this interaction, a CH3H interaction. This staggered, this eclipse conformation possess little bit higher energy than the previous case. So the energy difference enhances, but the type of graph remains same in case of ethane and propane. Now, the energy profile diagram of butane, conformational analysis or energy profile diagram of butane. If we see this butane from here, that is, if we see this is a front carbon and this is the back carbon, and in all this in this front carbon there are 2 hydrogen 1 methyl, and in this case also there is 2 hydrogen 1 methyl. So to remembering you, this is a according to Clement-Prelog terminology, since these both 2 hydrogens are same, this is methyl, which is the different one, and for the back carbon also this methyl is the different one. So I am taking these two as a fiducial group. The fiducial group according to Clement-Prelog terminology is 2 methyl. I am starting from here. This is for your just for your previous ক্লাসের যে মনে করিয়ে দেওয়াটা সেটাই করলাম, যে these are the but you can start anywhere from this molecule. I will prefer to start from here actually. So and this is nothing but a discussion for before to your previous class. So this 2 methyl, I am starting from this molecule, this conformation, and after 60-degree rotation we are getting this one, again 60-degree 120-degree after when the dihedral angle is to 120-degree in between these 2 methyl group. Eclipse structure is like this: 180-degree, 240-degree, 300-degree, and at last 360-degree, and these 360-degree both of them are identical. So now we can see here is 1 methyl-methyl interaction and 2 hydrogen-hydrogen interaction, and this in this eclipse conformation and this eclipse conformation there are 2 MEH interaction and 1 HH interaction, 2 MEH interaction and 1 HH interaction. So it is for your understanding I am giving you a data which is the methyl-methyl interaction is much higher than 2 methyl H interaction. So this is energetically higher, and this is identical with that. So these 2 are energetically higher one, and these 2 are energetically higher one with same energy. Now if we consider the conformers, 3 conformers, there is 2 gauge and 1 anti, you know that. Now this in this case, in this anti conformation or this for this conformer, these 2 methyl group are 180-degree dihedral angle relationship, less bulky, less steric hindrance over here, whereas in gauge conformation in both of them their dihedral angle relationship is 60-degree. Here is also 60-degree. So their steric interaction is little bit higher than anti-conformation. So there is some energy difference between 2 conformers, and the energy is 0.8 to 0.9 kilocalorie per mole. Here I have written 0.88 kilocalorie per mole, and this is, we know that this is the gauge butane interaction. So there is again among 3 conformer, 2 are of same energy and little bit higher energy, and 1 is the lowest energy content. The graph is like this. So the graph is like this, not like previous two cases. Now, conformation analysis of 2-methylbutane. If we substitute, this is our butane fragment. In 2 position, there is 1 methyl group. Now, we can start from here, keeping in mind the Clement Prelog terminology. 2 methyl groups are same. We are seeing from this side we are seeing, and here this is the front carbon. In this front carbon there is 2 methyl and 1 hydrogen over here, and in the back carbon there is 1 methyl and 2 hydrogen over here. So I am again starting from choosing the 2 fiducial group. For the front carbon, hydrogen is the fiducial group. For the back carbon, methyl is the fiducial group. Again, I am telling that this is not the mandatory for drawing the conformations, but I am doing like this. Now, this is the energy profile diagram of 2-methylbutane. This is F. Methyl is after 60 degree rotation coming over here, 120 degree over here, 180 degree over here, 240 degree over here, 300 degree over here, and these two are identical with the starting conformation. Now, if we consider the energy profile energy content of 3 conformers, we will see that here 2 methyl, 1 hydrogen, then after 1 hydrogen there is 1 methyl and then 2 hydrogen. And here is also 2 hydrogen, 1 methyl, 1 hydrogen, then 2 methyl group. So these two are identical, and higher energy content, the energy content of these two is lower than in case of this, because in this case when this hydrogen and methyl is 180 degree relationship, dihedral angle, 1 H and methyl between, then these 3 methyl groups are simultaneous 3 methyl group and then simultaneous 3 hydrogens over here. So this molecule has some higher energy than these two conformers. Sorry, not molecule, this conformer has some little bit higher energy than these two conformer. So this is the condition of 3 conformers, and if we consider the eclipsed one, then here is 1 methyl-methyl interaction, 1 CH3 methyl hydrogen interaction, and 1 hydrogen-hydrogen interaction. Similarly, over here also 1 methyl-methyl interaction, 1 methyl hydrogen interaction, and 1 hydrogen-hydrogen interaction. But in this case, there is 3 methyl hydrogen interaction. I have already said that 1 methyl-methyl interaction is much more than 2 methyl hydrogen interaction. So this is little bit lower energy content. And according to that, we are drawing our energy profile diagram like this, and this is our energy profile or conformation analysis of 2-methylbutane. Now, this is your homework. You have to draw the potential energy versus dihedral angle diagram starting from this eclipse conformation, and you will see how the energy profile diagram looks like. Now, the most important conformation analysis of 2,3-dimethylbutane. This is the butane fragment. This is 2 and this is 3. Whatever it may be 2, it may be 3. So this is 2,3-dimethylbutane. Now we are starting from, again keeping in the mind this, this is the, if two groups are same, third one will be the fiducial group. Keeping in mind, I am drawing this conformation starting from this conformation, this eclipsed conformation. 6-degree rotation, hydrogen will go over here. Then after 6-degree rotation, hydrogen will go over here. After 60-degree, hydrogen will go over here. Again 60-degree, hydrogen will go over here. Again 60-degree rotation, hydrogen will go over here. And then the identical one with this. This is 60, 120, 180, 240, 300 and 360. Now, if we draw comparison of potential energy of antiform of N-butane and 2,3-dimethylbutane. Antiform of N-butane and 2,3-dimethylbutane. Now this is the antiform of butane. And in butane, CH3CH. This angle is close to tetrahedron. This angle is close to tetrahedron. Mane, if we consider one methane, this is absolutely tetrahedron. One carbon, and surrounding this carbon there is 4 bond containing hydrogen, CH bond, 4 CH bond, and these are the perfectly tetrahedron molecule. But when this one hydrogen is replaced by methyl, then we are saying that this is very close to tetrahedron. Now, if we consider the 2,3-dimethylbutane, antiform of 2,3-dimethylbutane, this is the antiform of 2,3-dimethylbutane, and this angle, methyl, carbon, methyl, this angle, this one, this angle, and there is another angle methyl, back carbon, and this methyl. This is the back carbon. Now, this angle opens up to 114 degree. This means this is 109.28 মিনিট, মানে 109 ডিগ্রি 28 মিনিট এই অ্যাঙ্গেলটা। মিথাইল, কার্বন, হাইড্রোজেন এটা ক্লোজ টু 109.28. But in this case, methyl, carbon, methyl, being 2 methyl groups over here, they are feeling some kind of steric interaction, and for that reason this angle opens up. This angle opens up. I am coming. In case of both front carbon and the back carbon, as a result, the structure of 2,3-dimethylbutane, this A, becomes like A prime. That is, this angle is open up. So this angle becomes greater than previous one. And again the back carbon, there is a methyl carbon methyl angle. This is again opens up. That means it is a bigger angle than this one. That structure is looking like A prime, not like A. Now, this structure A prime shows 2 methyl group almost eclipsing. They are becoming in the position of eclipsing condition and suffers from van der Waals repulsion. Thus, potential energy of anticonformer of 2,3-dimethylbutane is more than potential energy of anticonformer of N-butane. And therefore, the potential energy of antiform of 2,3-dimethylbutane is somewhat greater than the antiform of N-butane. Now I am describing little bit more elaborately that if we if we think about this angle, these two methyl will get destabilized due to their bulkiness, and they will try to move like this. This methyl will go over here, this methyl will go over here. Again, for the back carbon, these two methyl will try to go over here, and this methyl will try to go over here like this. As a result, this A prime will generate. And due to generation of A prime structure, these two methyl group will suffer van der Waals repulsion and becoming almost eclipsing to each other. So, as we think that anticonformer is where according to butane, I'm going over here there. That is the conformation analysis of butane. According to conformation analysis of butane, we are thinking that 2,3-dimethyl butane will be over here. Not that. This is not the case. It will suffer eclipsing interaction, almost eclipsing interaction of two methyl groups, as I shown you, and it will be somewhat about higher energy, and it will reside over here, something like this. And if we consider the couch conformation of 2,3-dimethyl couch conformation of N-butane, this is the couch conformation of N-butane. Again, the angle methyl carbon hydrogen angle is, or methyl carbon hydrogen, this angle is near to tetrahedron. But in case of 2,3-dimethyl butane, this angle opens up to 114 degree. That is, this 2-methyl goes over like this. I will come now. The potential energy of couch conformer becomes lower than expected. Dihedral angle between two methyl group in couch conformer tends towards right angle. I am coming. As a result, two CH groups going to be perpendicular. Van der Waals repulsion minimizes. Couch conformer gets higher stability than expected. Mane, these two methyl group goes over here. They will try to open up to 114 degree. That is, this angle now becomes like this. And for the couch conformation, this methyl will goes over here, as I shown here. This methyl will goes over here. This methyl will goes over here. So this methyl will goes over here, like something like this. In this case, again hierarchy, or this methyl over here. So what is happening here? They are close to 90 degree. This methyl will be like here in this case. So they are going such a way that they are now not in close proximity. They are far apart. That does not mean I am not telling that they are far apart. They are moving from one another. Due to this case, in previous case, methyl will coming closer to one another. This is going over here, this is here, and this is coming over near over here and here, and these methyl groups are becoming close to each other. And in this case, when these two methyl is going over there, and this is again going over here, so this is also going over here, this is again, their distance between these methyls are increasing. They are tending, dihedral angle of Gauss conformation tending towards 90 degree. They are becoming right angle. Their distance between the methyls are increasing, and the energy van der Waals repulsion minimizes. This is not totally off. This is minimizing the van der Waals energy repulsion, because they are going far from each other. Thus, Gauss conformation gets higher stability than expected. That is, the four methyl groups are over here. We are thinking that this is getting a higher, very much destabilizing factor over here. But due to this van der Waals repulsion, this energy content is not according to our expectation. They gets something higher stability, and this becomes B prime. So the conformational analysis of 2,3-dimethyl butane, anti and Gauss conformer are nearly equal to same energy becomes. Now all three conformers, 2 Gauss and 1 anti, are of comparable energy. All three conformers are nearly equally populated at all temperature, which is again evident from Raman, Iyer and NMR spectra. The conformational free energy is nearly zero or very small. কেন আমরা ভেবেছিলাম যে অ্যান্টি আর গাউচের মধ্যে একটা এরকম একটা এনার্জি ডিফারেন্স থাকবে, কারণ গাউচের 4টে মিথাইল পরপর আছে আমরা দেখলাম, বাট দেয়ার ইজ নো এনার্জি, that is not no, there is a very small energy difference between gauge or anti-form. That is, gauge is getting much more stability, so it is coming like this, and anti is getting destabilized, so it is going over here. So the energy difference between gauge and anti minimizes. So since the energy difference between gauge form and anti form is minimizes, they are coming in the same line, nearly same line. Now all three conformers, 2 gauge and 1 anti of 2,3-dimethyl butane, are becoming of comparable energy, and if their energy is same towards equilibrium, they will contribute equally. As a result, concentration of gauge form, this is twice that of anti form, since there are 2 gauge conformation and 1 anti conformation. And this is all for today. My reference is Stereochemistry book by Subrata Sengupta, by Noshipuri, by LL, and some pictures are taken from Google site. This too is my YouTube link for previous class, and this will, and thank you.